My name is Aman and welcome to a third part of series of complex number. So in this part we are going to see how to find the module and the argument of complex number. So to solve the questions of modules we first need to look at the formula for module. So we represent a complex number by z, like we represent whole number by w, natural number by n, just like that we represent complex number by z. So module of z means module of complex number is under root a square plus b square. This is the formula to find the module of complex number. Suppose the question given is to find the module of 1 plus root 3 iota. So we will use the formula. Formula says under root a square, that is under root 1 square plus under root b square, means under root 3 whole square. So we just have to solve it. 1 square is 1 and root 3 square is 3. This is under root. It is under root 4, that is 2. So 2 is the module of this given complex number. Let's take another example. So they ask us to find the module of this complex number. This is 0. There is no imaginary number in it. So we just have to add an imaginary number to it. So it will get a complex number. So now we have a complex number and we have to use the same formula to find the module of 0 plus 0 iota. So it is under root a square means 0 square, b square, 0 square. So it is under root 0 plus 0 is 0, under root 0 is 0. So 0 is the module of 0 plus 0 iota. Let's take one more example. Suppose we have 4 minus 9 iota. So we can solve it with the same formula. So formula says under root 4 square is 16 plus 9 square is 81. So we'll get under root 97. So we got the module for 4 minus 9 iota. Let's take a last example. Suppose we have minus 8 plus 6 iota. Again by applying the formula under root a square, that is minus 8's whole square, so it is 64, then plus b square, that is 36 square. So it is under root 100, that is 10. So 10 is the module of minus 8 plus 6 iota. I hope the concept of module is now clear. So let's move to the second part, that is argument. How to find the argument of a complex number. To find the argument of complex number, first need to look at formula. Again there is a formula for an argument. So it is like argument of z. And formula says tan inverse b upon a. So this is the formula, tan inverse b upon a, to find the argument of a complex number. So let's take an example to do this. Suppose we have 1 plus iota and they ask us to find the module of 1 plus iota. So before solving the question, first need to learn the formulas of graph. So everyone knows this graph, that x axis are positive and y axis are negative. So there are 4 quadrants in it. There is first, second, third, fourth. So according to first quadrant, the first quadrant is plus and plus because both the axes in first quadrant are of positive, so it is plus and plus. The formula for this quadrant is theta is equals to alpha. Second quadrant is the axis that is horizontal is y axis, that is negative, and the axis that is vertical is positive axis, that is x axis. So it is minus plus second quadrant. So the formula for this quadrant is theta is equals to pi minus alpha. Same goes for third quadrant is minus and minus because both the axes are negative. For the formula for this quadrant is theta is equals to alpha minus pi, and last quadrant, that is plus minus, here theta is equals to minus alpha. So these are the formulas. So how to apply these formulas? So let's put it aside. So if they are asked us to find the argument of 1 plus iota, so we can apply this formula. like tan inverse b upon a. B in this case is coefficient of iota, that is 1, and upon a means 1. So 1 upon 1 is nothing but 1. So if you remember the trigonometric ratios of tan, that is 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. So tan 0 degree is 0 degree, tan 30 is 1 upon root 3, tan 45 is 1, tan 60 is root 3, and this is not defined. So we get the value 1 if there is tan 45 degree. So we can write it as tan inverse and then tan 45 degree. Nothing is going to change, we have just replaced 1 by tan 45 degree because value of tan 45 is nothing but 1. So the tan will get cancelled out by this tan, so we are just remaining with 45 degree. So we'll keep it equals to alpha. So the solution we get, we always keep it equals to alpha. So this is our solution. So we'll write it in the form of pi, that is pi upon 4. So why pi upon 4? Because we assume, no, not we assume, but the value of pi is 180 degree. Why? Because if you remember the formula of mensuration, that is circumference of circle 2 pi r. So here radius that always varies, but the 2 pi that remains constant, because means the radius of circle always changes. Sometimes it is 7, 3.5, 14, or etc, something like that, but 2 pi never changes, it is constant. So 2 pi is equals to, circle is of 360 degree, so is 360 degree. So pi remains, 2 is in multiple, it get to right hand side, and it will get divided by it will divide 360. So we'll get 360 upon 2, that is 180 degree. So by this logic we get pi as 180 degree. So we'll take pi, and by which number should we divide pi to get 45 degree? So if we divide 180 by 4, we will get 45 degree. So this is the form of pi to write the solution. So now let's take the formula. Now what is this use of formula? So here first quadrant is plus and plus. The given complex number has the signs as plus and plus, so we have to use the formula of first quadrant, that is theta is equals to alpha. So theta is equals to alpha, and alpha is pi upon 4. So we can say that our theta is equals to pi upon 4, that is our argument for the given complex number 1 plus iota. So let's take another example. Suppose we have to do root 3 plus iota, negative root 3 and plus iota. So again we have to find the argument of this. So again we have to apply this formula, tan inverse b upon a. So we'll apply this formula, that is tan inverse b is coefficient of iota, and coefficient of iota is 1, and negative root 3. So there is a property of argument that says that a or b, if any one of them is having a negative sign, we can take that negative sign to tan, like negative tan inverse and then 1 upon root 3, because we have taken this negative sign to tan. So we are just left with 1 upon root 3. So 1 upon root 3 is tan 30 degrees, so we can write it as negative tan inverse and then tan 30 degree. So this tan will get cancelled out, but this tan we are just left with 30 degrees, so we'll keep it equals to alpha. So now we have our alpha as 30 degree, so we have to write it in the form of pi. This pi, that is 180 degree, and if we divide 180 by 6, we get 30 degree. So now here we can see that the first digit that is real having the sign of negative, and the second digit, second term, having the positive sign. So we have the signs as negative and positive. So we have the sign as minus plus, so we have to use the quadrant of, we have to use the formula of second quadrant, that is minus plus, because the signs are minus plus of the given complex number. So we have to use the formula of theta is equals to pi minus alpha. We have to use this formula to find the solution, to find the argument of this complex number. So the formula says pi minus alpha. So we get theta pi, we have our alpha as pi upon 6. So we can find the value of theta by cross multiplying. So it will get 6 pi minus pi upon 6. So the value of theta is 5 pi upon 6. So this is our argument of negative 3 plus iota. So let's take one more example. Suppose we have to they have given us just 0 iota, so there is no real number in it, so we can add a real number 0. If no real number is given, we can take it as 0, and if no imaginary number is given, then we can take it as 0 iota. So 0 plus 0 iota, we have to find the argument. The formula for that is tan inverse b upon a. So we can write it as argument of z is tan inverse b. B is coefficient of 0, that is coefficient of iota, that is 0, upon a, that is real number, that is also 0. So it is 0 in denominator, so it is not defined, and tan 90 degree is also not defined, so we can take it as tan 90 degree. So this tan will get cancelled out with this tan. We are just left with 90 degree, that is equals to alpha. So here's plus and plus, so we have to use the formula of first quadrant again, that is theta is equals to alpha. So our theta is equals to alpha is equals to 90 degree, and we have to write it in the form of pi. So our pi is 180 degree, and if we divide it by 2, we'll get 90 degree. So pi upon 2 is our argument for 0 plus 0 iota. Let's take one more example. Suppose we have negative 7 plus 28 iota. How to solve it? Again, by using the formula tan inverse b, that is 28 upon a, that is negative 7. So tan inverse, this 7 will get cancelled out by 28, so we are just left with negative 4. This negative sign we can take it to tan, just left with negative tan inverse 4. So there is no 4 in the trigonometric ratios of tan, so this is our argument, we can left it here. So negative tan inverse 4 is our argument for minus 7 plus 28 iota. Let's take the last example. Suppose we have negative 1 and negative root 3 iota. Again, they ask us to find the argument. So again, by applying formula tan inverse b, that is root 3 upon a, that is 1 negative. So this negative sign will get cancelled by this. So tan inverse root 3 upon 1, that is root 3, and that is also tan 60 degree. So this tan will get cancelled out with this tan. We are left with 60 degree, that is equals to alpha, and in the form of pi we can write it as pi means 180 upon 3. So we'll get 60 degree. So now we have to use the formula. So complex numbers having both the signs as negative, so we have to use the quadrant, we have to use the formula of third quadrant, that is minus and minus. So formula says theta is equals to alpha minus pi, so we'll take as theta is equals to alpha minus pi. So theta is equals to alpha, that is pi minus 3 minus pi. So we are left with pi minus 3 pi upon 3 is equals to theta. So we are just left with negative 2 pi upon 3. So this is our argument of negative 1 minus negative under root 3 iota. So I hope your concept of argument and module is clear. So last point remaining, that is of polar form, we will learn it in fourth part of this video. So bye bye.